right, here's an example where we want to find the coordinates of the missing x in this Voronoi diagram. So we have some cells that have already been identified. So we have a point, cell A, a point, cell B, a point, cell C, and then a cell D. And we're missing one point, which we'll call X, that's in this cell right here. So we want to find out what is that point. So we're going to go ahead and start to label some of these points. So point A has the coordinate left 3, up 3. I'm just going to erase this yellow so you can kind of start to see. And then there's that green X. Okay. So when we have point A, I'm just labeling it off to the side, we want to find out what is going to be the perpendicular bisector for this edge right here, this pink edge. So notice that it runs parallel. So to create a perpendicular line, we're going to be going at a 90-degree measure. So it's going to be straight up and down. So that perpendicular bisector of that edge, that pink edge, is going to be a vertical line. Now we want to find the distance from point A down to point X. So that distance is 2 units to that edge, and then 2 units to that next point X. So that midpoint is our edge right here at over -3 up 1. So that would be our X point. So our X point is -3, 1. So from A to the edge is 2 units, and from the edge, that pink edge, to X is also 2 units. All right. Heading now down to part 2, I'd call this. We have this point sitting down here, point D, and we want to create the perpendicular bisector from D to X. So here is point D to X, and then there's another edge that's going to run along here, creating this 90-degree measure, creating that perpendicular. So let's identify point D. So point D is -2, -4, and then X is -3, -1. So let's go ahead and find the slope of dx. So it's going to be the change in y, so -1 minus -4 over the change in x, -3 minus -2. Now we're going to go ahead and simplify. We're going to get 3 in the numerator and -1 in the denominator. So that slope of dx is -3. You can kind of see that too graphically. Down 3, right 1. All right, so then the perpendicular line, this purple edge right here, I'll just color that in red, that perpendicular bisector of dx would be the negative reciprocal, so it's going to be positive 1/3. All right, continuing on. If we draw lines AX, so here's A to X, dashed line, color that in pink, and DX, dashed line, through point A and D, they intersect at point X. So here is its intersection. Those two lines intersect. That coordinate of X is left 3, down 1. The X coordinate is -3, -1. All right, continuing on, taking that graph one step further. So we've just created this dashed, whoops, don't want that. We have this dashed line from A to X, and then we have this dashed line from D to X, and then notice we have from point B to X running through the origin, a vertice, and then we have point C to X running through that vertice, creating that point X. So just to kind of wrap it up, this is just kind of taking that problem that we just did. There was no site in that missing X. So we found the perpendicular bisector of AX is horizontal. The perpendicular bisector of DX has a slope of 1/3. So then we would have AX is vertical and DX has a slope of -3. And then we would draw those lines, giving us the point intersecting at -3, -1.